This session is related to exercises from topic 7, which is about the chemical reaction, and the subtopics are rate of the reaction, redox, as well as reversible reaction. So the first part we will discuss the question related to rate of the reaction. This is exercise 2. Exercise 1 was about the MCQ's multiple choice question, which we already discussed. In this question, when aqueous sodium thiosulfate is there, so this is sodium thiosulfate, Na2S2O3. So when aqueous sodium thiosulfate is mixed with hydrochloric acid, a precipitate of sulfur is formed. Precipitate means when we mix two solution and a solid is formed, we call that as precipitate. So when the precipitate will form, this cross which is underneath this conical flask, this cross will disappear. We will not be able to see this cross because when the precipitate form, the light cannot pass through the solid. That's why we are not able to see the cross which is underneath this conical flask. A student, so in the experiment, what student did? A student adds the following volumes of a thiosulfate solution and hydrochloric acid as well as water, distilled water. The time for the formation of the precipitate for a sulfur to make the cross disappeared is viewed. So if in the first part, when we use 10 cm cube of thiosulfate, 10 cm cube of hydrochloric acid and 40 cm cube of water, the time it took to disappear was 56. The second experiment, we took 20 cm cube of thiosulfate, 10 cm cube of hydrochloric acid and 30 cm cube of distilled water. It disappeared in 28 seconds. State the order in which the aqueous sodium thiosulfate, hydrochloric acid and water should be added. Water is not the reactant here. The purpose of the water so that the total volume of the solution will be same, because 10 plus 10 plus 40, so the total volume is 60. Same thing, 20 plus 10 plus 30, so the total volume is 60. So water is not the reactant here. Water is basically to make the total volume same so that the one which will have a greater volume in the mixture will have a high concentration or greater number of the particles. So what should be the order? So if we first add thiosulfate, it can be any order, but water should not be at the last. Any order is acceptable, but water should not be at the last, because if you add water at the last, then it is no use of adding water, because the purpose of the water is to make the solution final volume of or all the experiment same, but water is not the reactant here. So what order we can follow? It can be thiosulfate or sodium thiosulfate, then second we will add water to make solution final volume same, and at the last, for a reaction to occur, we can add hydrochloric. So why we are adding hydrochloric acid at the last? Because if thiosulfate and hydrochloric acid are added in the beginning, then what they will do, they will instantly react with each other. Then the use of the water, it will not be effective. Like there will be no use of adding water to the mixture. That's why whenever we are carrying out this experiment, it can be other way around. It can be hydrochloric acid, then water, then thiosulfate, or it can be water, hydrochloric acid and thiosulfate, or water, thiosulfate and then hydrochloric. But water cannot be at the last. In experiment 3, student wanted the thiosulfate to be double concentration. And experiment 2, complete the table. So if we want double concentration, we want more thiosulfate compared to experiment 2. So experiment 2, student was using 20 cm cube. So he want to double the amount of thiosulfate. So what is double of 20? So it means he will use 40 cm cube of thiosulfate. The hydrochloric acid amount is not changed, so it is 10. Now what should be the amount of the water? Because the total sum of the volume, when you add 10 plus 10 plus 40, so the sum of the volume was 60. Then 20 plus 10 plus 30, so sum of volume was 60. So same way 40 plus 10 plus 10, so the total volume will be 60. Then use the collision theory. We have to complete to show the volume and expected time. So what could be the expected time? because if you are using more volume, it means greater concentration. So if we double the concentration, the rate of the reaction will also be double. So the cross, we know rate and time are inversely proportional. So if when we were using 20 cm cube of thiosulfate, the cross disappear in 28 seconds. But if you use 40 cm cube of thiosulfate, like double the volume, then the time for the cross to reaction will be faster and the cross will disappear in a short time. So if the amount of concentration is double, the time will be half. So if it was taking 28 seconds, the half of 28 seconds, it will be 14 seconds. Is it clear how we complete the table? Any doubt in this part? In the next question, use the collision theory why increasing the concentration of thiosulfate will increase the rate of reaction. So when we increase the concentration, will increase the number of effective collision, which increase the rate. The student repeated the experiment at higher temperature. Using a collision theory, what will be the effect if we use a higher temperature? So when we increase the temperature, the particles have more energy. It will increase the number of the collision as well, or more collision in a unit time. And it's of 3 marks. So how you will get the 3 marks? Number one, you will mention increase in temperature will increase the energy of the particle. That's one thing. And the number of the collisions will increase. And at last, what happened? That the greater proportion of the molecules have energy more than activation energy. So when greater proportion of molecule will have energy more than activation energy, as a result, the rate of the reaction will increase as well. The second question, magnesium carbonate react with dilute hydrochloric acid. So magnesium plus hydrochloric acid give magnesium chloride, water and carbon dioxide. An excess of magnesium carbonate pieces are added, like we add more than enough we need for reaction to occur. The apparatus in the diagram used to measure the volume of the gas produced. The total volume of the gas collected was recorded every 20 seconds. So this is the total volume of the gas which is collected. We measure after every 20 seconds. Describe how the rate of reaction changes during the reaction. Explain why the rate change in this way. So it's a 4 marks. And you have to write in detail what happened. So in the beginning, overall what happened, the rate decreases, the rate of the reaction decrease. And what is the reason why the rate of the reaction is decreasing? Because the number of the particles, the number of reactant particles are decreasing. So there will be few collision or less collisions between the particles, and until all the acid, because magnesium carbonate is in excess, so we cannot say magnesium carbonate use up. So we will mention all the acid used up. So reaction stops. So in the beginning you will have more particle, that's why there's a faster rate. as a steeper slope is there, but with the passage of the time, the slope is decreasing, rate is decreasing, and eventually the rate will be zero. Why the rate is zero? Even you will have, because excess of magnesium carbonate means you have more than enough magnesium carbonate, but the acid is used up. The next part, the experiment was repeated using a powdered magnesium carbonate with the same amount of acid. Explain how the initial rate and the total volume. So how the initial rate will be affected, like rate of the reaction or initial rate or the starting rate, it will be affected. So it will be faster because, so initial rate will be faster. And what is the reason for that? Because powdered magnesium carbonate have large surface area. So when there's a large surface area, the rate of the reaction will be faster. Then what will happen to the total volume? Because we did not change the amount, we did not change amount of the acid, and magnesium carbonate is already in excess, like more than enough. So that what will happen, the total volume of the gas will be same volume of the gas will be produced. And what is the reason for that? Because the number of the particles, number of reactant particles does not change. Like we are using the same amount of reactant, but the only difference, the first experiment, uh, like example, if you was having say 2 grams of magnesium carbonate, but in the second experiment we have 2 gram, but that 2 gram is powdered. So powdered magnesium carbonate, it will have a large surface area as compared to a solid lump. So when we compare both of them, the reaction will be faster in the second experiment, but the total amount of the product which is formed when they react, because the amount is same, so the total amount of the reactant is same, so amount of product is not affected, so it will also be same amount. Is it clear discussion? Then a piece of magnesium, in the question, a piece of magnesium ribbon was cleaned. The experiment was repeated using a clean magnesium ribbon instead of magnesium carbonate. So instead of magnesium carbonate, we are using magnesium ribbon. This reaction is exothermic. The rate of a reaction gradually increases over a time. Explain why the rate of reaction increase, and it's a 5 marks. So, and they mentioned the reaction is exothermic. The term exothermic reaction means it will release the heat energy. So the reaction is exothermic. It will release heat energy. So the temperature of the mixture will increase. As the temperature of the mixture increase, there will be more collisions between the particles. The energy of the particle will increase. And number of the collision will also increase. And there will be greater number of the particles have energy more than activation energy. So greater proportion, greater number of the particle will have energy more than activation energy. So as a result, the rate will increase, because the rate of the reaction is directly proportional to the number of the collision. So as the temperature increases, the number of the collision increase, and due to increase in number of the collision, the speed or the rate of the reaction will also increase. So these are always the points which you have to keep in mind whenever you're talking about temperature. In question 3, a student investigated the progress of reaction between dilute hydrochloric acid and excess of large pieces of calcium carbonate. So he's using large pieces of calcium carbonate. This is a graph which is plotted. How does the shape of a graph shows that the rate decreases as a reaction progress? Like as the reaction proceed or reaction progress, the rate of the reaction is decreasing. Because the gradient of a tangent is representing the rate. So what is happening? The gradient is decreasing, or we can say the gradient represent the rate of the reaction. So the slope or the gradient decreases, which shows that the rate of the reaction is also decreasing. If the slope increase, then the rate of the reaction will also increase. Then the second part, why did the rate decreases as the reaction progress? So why the rate is decreasing? Because in the beginning you will have more particles of the reactant, but with the passage of the time, the number of the reactant particles, decrease. That's why the rate of the reaction is also decreasing. After how many seconds did the reaction finish? So how we can identify when the reaction finish? So when the line is horizontal, the moment when the line turn out to be horizontal, that is a moment when the reaction finished. So it appeared to be like around this is a starting point of horizontal line. So when it is a horizontal line, it means you're not getting any change in the product. So this time interval, the reaction completed. So it is 120 seconds. The experiment was repeated using a same mass. We are using a same mass but smaller pieces of marble. All other conditions are same. Draw on the graph. So because if you use a small pieces, it will have be large surface area, and large surface area, the rate will be faster. But only it will affect the rate. Amount of the product won't change as we are using a same amount of the reactant. The only difference, we are using a large surface area, small particle size, large surface area, so the reaction will be faster. We'll draw a steeper one, but the final amount should be same. And some student, they make a common mistake here, like they draw in this manner, like first it increases and then drawing like this. So that is also wrong. What you have to show, that the reaction will complete in a short time and it will be steeper, but the final product should be same. So this will be the graph when we are using a small marble chips, or we are using a large surface area or crushed or a powdered form. Is it clear this part, that how we explain that the rate become faster as we are using a small area? Part B. Is it clear? Then the next, it's again, see the weightage of the marks, it's a 5-mark question and very straightforward and simple answers are there. That original experiment was repeated at a higher temperature. If we use higher temperature, what will be how it will affect the rate? So first, what will happen when we increase the temperature? Will increase the rate of the reaction. That is one thing. And but why it happened? Because the particles will have more energy. So frequently they will collide. The particles have more energy. They will move faster. And more collisions will be there. Then greater number of the particles will have energy more than activation energy. So greater proportion or greater number of the particle will have energy more than activation energy. What is the weightage of the mark? Like how you will get the 5 marks? First, if you mention the rate of the reaction increases, then this will give you 1 mark. Then the particle have more energy, that is a second mark. They will move faster, that is a third mark. They will have more collision, that is a fourth. And then greater number of particle have energy more than activation energy, that will be the fifth one. So sufficient amount of energy is there for particle to react, or greater number of particle have energy more than activation. So this is how the marks are distributed. So whenever there is a change in temperature, you will always try to use this journal answer, that when we increase the temperature, the first thing, the rate of the reaction increases. And the reason is that because the particles have more energy, they will move faster, they will collide often, and as a result the rate is increasing, as well as greater proportion or greater number of the particle have energy more than activation, so they can react easily. So whenever you're writing the answer, this is always a general answer. Sometimes this question is of 4 marks, sometimes it is of 5 marks, but you will always write this answer when you're comparing the temperature, the effect of temperature on the rate of the reaction. Another question: a student investigate the rate of a reaction between lumps of calcium, like pieces of calcium, and hydrochloric acid. The calcium carbonate was in excess, like more than enough. Which measurement should the student make during this reaction to determine the rate? So if student want to measure the rate, so he can measure the change in mass of the reactant, or he can measure the amount of product form. But because a gas syringe is connected here, so what a student can do, he can measure the volume of the gas and the time interval, and how he can measure, or how he can find the rate, that is a change in the volume. So rate will be equal to change in volume of the gas, which is a product here, divided by time. What happened to rate of a reaction as the reaction proceeds? So rate of reaction always decreases. The rate in the beginning you will have faster, but rate will decrease. And what is the reason why the rate of the reaction decreases? Because less particles, or the number of the reactant particle decreases. In the beginning you will have maximum number, so the number of the reactant particles decrease, so less collision, result in decrease in rate of the reaction. In the beginning you will have more particles of calcium carbonate and hydrochloric acid, but with the passage of the time, because these particles are reacting and forming a product, so the number of the reactant particles are decreasing. That's why the rate of the reaction will also decrease. Then question 3, student repeated the experiment at higher temperatures. Same question, same pattern, but it's of 4 marks. So the same answer I should write. What I will write in terms of collision, we have to explain this. So first thing we'll mention the rate will increase, because as we increase the temperature, rate will increase. The increase in temperature will increase the rate of reaction. Then second, what happened? The particles, the energy of the particle increases, and move faster. Then what happened? More collisions, more frequent collision or more collisions between the particles. And as the number of the collision increases, the rate will increase, and greater number of the particles have energy more than activation energy. The greater proportion, so the increase in temperature will increase the rate of reaction. That's one mark. Particles have more energy and they will move faster. That is second mark. Like sometime more energy and move faster is having like two, saying one, 2 marks, and sometimes they only specify them as same as, so they give 1 mark. Then more collision between the particles will be there. That's the third mark. And greater number of the particles have energy more than activation energy. That will be the fourth mark. Apart from using a higher temperature, suggest two methods to increase the rate. So which two methods can increase the rate? How we can change the rate of the reaction? We can use by changing the surface area, or what else we can use? We can change the concentration, because pressure can also affect the rate, or we can use a catalyst. But here in this example, we cannot write a pressure as the reactants are not in the gaseous state. The pressure is only affecting the gaseous rate of the gaseous reactant. So change the surface area or change the concentration or amount of the substance. Both will affect the rate of reaction, or you can also write by using a catalyst. Is it clear? So this was exercise related to rate of the reaction. There's another exercise I will share with you that is about reversible reaction and redox reactions.